Hello everyone, welcome to another Directions MAK Geospatial webinar, today sponsored by Melissa. I'm Barbary Duke, Managing Editor here at Directions Magazine, joined by my assistant webinar producer, Lynette Qualia. If you have any questions about your connection, just drop us a note in the chat. For those of you who don't know Directions, we have been around for 20 years and we encourage you to read our feature articles, daily news, and attend more webinars at directionsmag.com. We are a demo-only session today, but we are taking your questions. We're going to save those and share them with the team at Melissa, and they will follow up with you individually. So don't hesitate to type those in at any time. We do have a handout for you today, so we encourage you to download that. That's over in your control panel. We are recording as always, and you can expect an email from us with links and availability to see the recording, and we always appreciate your thoughts on the polls and survey. Today we have the honor of hearing from Mark Bernier. He is the Director of R&D at Melissa and is going to talk to us today about some address identifiers and ways to be more efficient in this manner. He's got some great tools for you that might be just what you need in your shop's toolbox. Mark, welcome.
Thank you. Good afternoon, everyone. I'm here to talk to you today about address identification and how you can use it to make your data and operations more efficient. Oh, there we go. As many of you know, address identification is not a new concept when working with data. Generally, there are three approaches you can use to determine if a pair of records refer to the same address or two different addresses. First of all, there's not to use any specific identification feature at all. Rather, you just look at the addresses in their plain string forms and compare them to each other. Obviously, this isn't a great method because typos, abbreviations, anything like that can cause all sorts of problems, and you won't find the duplicate matches. The second is to use a combination of the address component parts, and we'll talk a bit about that, but in brief, it's just splitting an address into its parts and using some of those parts to identify addresses. The third is to assign every address a unique identifier, and we'll talk about that a lot more since that's a very popular technique to do this. So first, talking about identification by components. So generally, you take an address like this and you split it into its parts using an address parser, and there's quite a few of those around that some of them are very reliable. So you're pulling your address into a range, a couple directionals, a street name, a suffix, and a suite, and zip in its parts. From this, you may decide that there are certain parts that are very significant, and in general, like the range, the suite, the zip, and the +4 are enough to identify an address uniquely in the US. So that's often a good way of identifying an address. However, there are problems with that, and that is that addresses change from month to month. In the US, on any given month, between 30 and 40,000 addresses will change in some way. And this isn't people who have just moved from one location to another, but rather people who live at the same place and someone's come along and told them, you aren't going by that address anymore. We have a new address that you need to call yourself. So there's a few reasons how this happens. And one is that the USPS is continually updating their data. They get complaints from customers or vendors telling them there's a misspelling or there's an inaccuracy, and they'll fix it and release it in the next monthly update. They also will remove addresses that no longer exist because of things like natural disasters. Second, there are changes that are sometimes made due to emergency response services. For instance, if you have an area where there are two streets, one is Miller Street and the other one's Miller Road, that the response services will often want to change one of those addresses to something like Smith Street so that there will be no confusion when someone calls with an emergency or something like that. There are also situations where there are street name changes. So a town might decide that they want to honor a veteran by renaming one of the streets. So that'll account for a change. And finally, there are sometimes zip code or +4 changes. And these generally happen when there's a large amount of growth in a certain area and the zip code, the USPS has to split a zip code into 2 zip codes or has to rearrange the +4s in a way to make things more efficient. So moving along, if you decide to go the route of identifying by unique identifier, you have a few options there. First, you can use a GUID to identify your address. Essentially, a GUID is a computer identified identifier. It's guaranteed to be unique. However, they're extremely long. They're very hard to read, and they're impossible to memorize. So you have those things going against it. Second, you could kind of use components. For instance, in this example here, I'm using the zip code, the +4, the range, and the suite range to identify this address. However, this has the same problem that we talked about in the earlier slide, where if the zip code changes, well, this number is no longer valid. So that's a big problem. Finally, the final method of using identifiers is just to assign a unique integer. So in this case, we've decided to use a 10-digit number, which is assigned to this particular address. And this is the way that Melissa actually uses its identification system. So there are a few considerations that you have to worry about with working with unique identifiers. First is that your system is going to be different from everyone else's. We use 10 digits, you might use 9, you might start with a different numbering system. They're all going to be different. So there's a good chance that if you're using it, no one else is going to be able to use it. Second, you have to worry about whether or not your identifiers are really unique. In today's systems where you have distributed databases, there's a chance that you have two nodes that might be assigning identifiers at the same time. And you have to worry about whether or not they might assign the very same identifier. There's ways around that. However, it is something you generally have to worry about. In a similar way, you also have to worry about whether or not addresses are really unique. Again, with a distributed system, it could be that you have two nodes that are looking at the very same address, and they might decide that they're both unique because they don't know about each other and assign them different numbers. So now you have one address that has two identifiers. That's something you don't want to happen. You also have to worry about merged addresses. So for instance, if you have an address that is a rural route, say rural route 5, box 10, and the USPS or emergency responses has now changed that into an urban address, so now it's 123 Main Street. It's like, well, you might have known about both of those addresses at one time. However, you didn't know that they were the same address, so you have to somehow merge them together. So now you have two identifiers that are really one. So that's a concern. In a similar way, you have to worry about alternate addresses. For instance, in a large city, you may have a building that takes up a whole block, and the building might have several entrances, maybe on each street. And each one of those entrances is perfectly valid. The USPS might deliver to each one, or at least considers them okay. And you have to be careful to make sure that they essentially get all the same identifier. You don't want to have 4 different numbers referring to the same building. And finally, there's a similar issue with +4s. Same type of building. Generally, we'll have one +4 assigned to it, which will be for the entire block side. Essentially, all the odd numbers on a particular street might get the same +4. But the building, if it's particularly big, will also get its own +4 because it's so large. And then sometimes inside there'll be a suite, and the suite might be big enough that it gets its own +4 as well. So that suite can be identified by 3 different +4s, and all 3 of them are perfectly valid. And you need to handle that particular situation, somehow equate them together. So with all that, you might not want to deal with that. Addresses are a fairly complicated thing to get into, and there's a lot of things to worry about. So luckily, Melissa has a solution for you, which we call the Melissa address key, or the MAK for short. Here's some of the features of the Melissa address key. First, you have an address like this, and we assign a 10-digit number. The 10-digit number is assigned in such a way that you can't reverse engineer it. There's no zip code or +4 or any kind of information hidden in this number that you could use to figure this out. Neighbors will not get adjacent numbers. The next number might be somewhere in Idaho or somewhere in Massachusetts. Who knows where the next one is. So yes, it can be reverse engineered. We're continually maintaining data on practically a daily basis. So you don't have to worry about the data being up to date. And we also provide several ways of retrieving the MAK through our web services, through our APIs, and so on. So we're working forward to make sure that you can work with the MAKs. So there are a few features of the MAK that I'd like to talk about. First, there's the concept of the base MAK. Basically, whenever the address has an apartment or a suite or PO box, we assign a MAK to that address, but we also can give you a base MAK, which is basically the MAK of the building that contains that thing. And you'll see later on that this is very important or very useful when you're trying to deduplicate addresses, because you can just use the MAK to do that, or the base MAK as well. We also have the concept of the merge MAK, which essentially just says that if you give me this address, this was what the MAK was at that time. However, it really is supposed to be this address. This is what they changed it to. so that you always have this kind of relation to make sure that you can go back and get the newest address from an old one. We never throw away the old addresses or reuse the MAKs. So you can give me this number 10 years from now, and I'll still be able to tell you it's going to be this or that it was that. So what are some of the benefits of using the MAK? First of all, there's a big space savings. A typical record like this could be somewhere between 70 and 200 or 300 bytes required to store all the address information. However, with the MAK is only a 64-bit number, so it's only an 8-byte requirement. So I can easily store, an address like this in 20 bytes. So you're talking easily a 4- or 5-fold improvement in terms of space. So that has an impact on the amount of disk space you need to store all this information. Also, when you maintain indexes, they don't need as much space, and also they can be worked with faster because there's a lot less information there. Your backups obviously don't need as much storage space either. And also network times are reduced because, again, not as much information is getting passed around. We also produce a MAK transaction table. Basically, every single change that's made to the MAK, we keep track of. We keep track of when it was done. We have the old and new, and we also have a codified system where we can tell you exactly what changed. Was it the street number, the street name, the city, or whatever? So you can use this with your own processing for a huge benefit, and that is something I'm going to give you a little scenario here. For instance, if you say recode or standardize your database every quarter so that you have the most up-to-date addresses that you can. So in that case, what you would do is you would go to our MAK transaction table and you would ask for the last 3 months of changes. And you might even further specify, I'm not interested in latitude or longitudes. All I care about is street address changes. So you get a set of data that describes that. So you take your database and you join it against that data, and that will effectively remove all the records that were not changed. And so basically you're just looking at changed records now. You take those addresses and you pass them through an address standardization product, for instance, Melissa Data's address object, or any of the others that are available. Then you take the results from that and you re-update them into your original database. So the savings here are quite real. If your database is, say, 100 million addresses, it's likely that only between 30 and 50,000 of those addresses actually changed over those last 3 months. So a process that could have been taking you hours or even days is now taking you a few minutes to process, and you've cut out an awful lot of extra processing there. So record deduplication is another benefit of using MAKs. For instance, in this example, you can see that we have one address here, which is very long and spelled out, basically a nice looking address. This one here, which has got a few contractions built into it or abbreviations built in so that it could fit on a label or whatever easier. With a lot of deduplication software, there's a bit of a problem. It's going to basically have a lexicon to figure out that center and CTR are the same and so on, or you have to work in things like fuzzy matching. It's not the most reliable way to do things. You wind up with false positives and missed stoops. It's not a science as much as it is an art. However, when you're working with MAKs, it is a science. The numbers are exactly the same. There's no mistaking here. It's a very efficient match. It's just one number you need to compare to each other. It's very fast. One of the other features is that we can match up bases to the specific suites. For instance, some of your data was missing suites like this record here. So we have this address, we know what the MAK is. However, we also know what the base is because that's part of the MAK system. This base matches exactly to this record because this record happens to be the base. So some of your matching algorithms may actually use the base compared to the MAK to actually find a base to a MAK match, as you see here. So that's the big benefit of in terms of record deduplication. So Melissa has integrated the MAK identifiers into our entire product line. For instance, we have it in our web services that use addresses. So for instance, a person in a geocoder and several others. We worked into a developer API so that we're talking about address object and geocoder again. Our ETL components. So if you're doing any ETL work with our SSIS or Pentaho components, you'll see the MAK appear there. And we also offer it with our GUI product. So if you're using ListWare for Excel or ListWare Online, you'll notice that the MAK is starting to appear there as well. So basically, with all of our products, if it works with an address, there's a very good chance that it's working with a MAK now. So one of the other benefits is customer privacy. When you just look at this record here, you really can't tell from where these records are located. I mean, it's just a number and you really can't make any sense out of it. So basically, a casual observer can't look at an address and look at a record and figure out where the person's located. It's likely that they're going to have to query another service or look at one of your other databases to figure that out. So basically, I'm not saying that it's an end-all solution to your privacy issues. However, it can be one layer in a much larger privacy solution for you. So everything we talked about so far has to do with your addresses and assigning MAKs to them, but you actually might be more interested in the addresses themselves. And that's where the Melissa address table comes in. And I'll tell you a few things about the Melissa address table. It contains 120 million street addresses, 22 million PO boxes, 51 million apartments and suites, and 5 million records that are deliverable or not deliverable by the USPS. So these are people who go to the post office to get their mail, or they just don't get their mail for some reason. However, they still get stuff. It's probably delivered to them by UPS or FedEx or something like that. And we know about these people. We have their addresses. We also have 6 million undeveloped addresses. So these are properties that actually don't have a structure on them yet. And you may find some of that information very useful, particularly if you're doing some GIS work. So what can you get along with the MAT? Well, basically, first of all, the MAT is updated at the same frequency as the MAK. So basically, very, very often. It's basically always up to date. We can provide geocode data, so you're looking at your high resolution latitude and longitude coordinates. We also use the new coordinate systems, GeoHash and Google Plus, so those are available to you. We can provide census data, the county, the FIPS, and so on. We can also provide demographic data, household size, children, things that are associated with the property. And we can also provide shape data, so the shape of the parcel when we have it available to us. Finally, if the webinar attendees will get a free evaluation of an address database if they have one, they send it in. We can tell you about it, and we can also give you an entire city's worth of latitudes and longitudes. There'll be more information on this in the follow-up email from us. So how can you get the MAT data? Our list service department will help you out in figuring out exactly what kind of MAT data you'll need or what section of the MAT you'll want to work with. Basically, you can select it through conventional terms, your city, state, zip +4, or you can give us a set of voting districts and we'll give information on that. Or you can just give us a set of points and we'll just give you a bunch of addresses that are near those points. Or basically any other shape you can give us, and we'll just give you all the points inside of them, or all the addresses, inside of them. You can further qualify a query by adding demographic data or property. So you may say, well, I only want addresses that have families in them and houses have to be worth more than, say, 300,000, because maybe you're doing some sort of special pool research or something. So what kind of uses would you have for the MAT? I'm going to hand this over to Barbara at this time so that she can take a little poll.
Right. So we'd like to learn more about what uses you have for the MAT. Maybe you're doing some analytics enrichment, resource allocation, utilities planning, mapping, or risk assessment. And while you guys are voting, I wanted also to call your attention to the chat. We have shared with you a link to the Melissa magazine. So that may be helpful to you in learning more about some use cases and stories going on over there with their clients. And remember, you can get that handout over in the control panel that gives you the MAT data sheet for you. All right, so let's share these results. It looks like the clear winner at 72% is mapping, and coming in second, analytics enrichment. All right, very good.
Okay, that's interesting. I hadn't been thinking about mapping too much as being the primary use. I'm kind of thinking probably to do with delivery or emergency services and figuring out best routes to areas, or perhaps just general mapping where people are looking to find all the addresses in a particular area or something like that. Just a few of the other uses that we talked about in the poll. For instance, analytics. You might find an area of your database where it's particularly weak in known addresses, and you may be needing to have a need to do some analytics in that area. So using the MAT might help you out in that way, because we can just basically give you a big bunch of records that will fill that hole for you. With resource allocation, if you're working with an area that you don't know a lot about, but you need to plan resources or logistics or something like that, again, we have addresses so that you can fill those holes in and get some numbers. Utilities the same way. If your utility might be planning on extending, say, coverage into a particular area, but you don't really know how many houses or how many addresses are there, or how many people are going to actually take advantage of your service. Or it may be a situation where you're trying to plan for repair teams and things like that associated with disasters, where you need to have a good idea of where the trouble spots are going to be and how many people are going to be affected when something happens. And finally, well, we already talked about mapping a bit. Risk assessment, for instance, insurance companies who may be looking for addresses that are in areas of risk, like floodplains or things like that. And so there's a few other uses that may come up from time to time that you hadn't thought of. So let's see. So hopefully you've learned a bit about the Melissa address key and the Melissa address table today. Like Barbara said, we have some handouts for more information. You also can get more information at our website, melissa.com. And you can also reach out to us at webinars@melissa.com if you have specific questions. And I think that's about it. Thank you.
Thanks, Mark. We really appreciate you sharing that with us today. Just want to remind everyone that the recording will be archived. You'll get an email with the link, as well as the resources and information how to check out that free trial that they're generously providing. That's wonderful. We also appreciate your completing the brief survey on the way out. Thanks again to Mark, and a little special thank you to Liz Frere, who's hanging out with us in the background and helping. We appreciate her as well. Thanks, everybody. We hope to see you at another Directions webinar. Make it a great day and tell a friend.